Every planet reflects some sunlight back into space instead of absorbing it. And scientists have a name for that fraction. Albedo. Earth's albedo has been quietly falling for 2 decades. Satellite records tracked by NASA and independent research groups show the planet is reflecting roughly 0.6 percentage points less sunlight than it did in 2000. A number small enough to sound trivial. It is not trivial, because Earth is absorbing that extra sunlight instead of bouncing it away. Researchers now estimate the planet's overall energy imbalance. The gap between energy coming in from the sun and energy leaving back to space has more than doubled since 2000. That imbalance is the direct engine behind rising global temperatures. This is not a new prediction. It is a measured trend. And it is running faster than most climate models expected even a decade ago. Let us sort the signal from the noise. Think of Earth's climate as a running balance sheet. Sunlight arrives constantly, and the planet is always doing 2 things with it: reflecting some straight back to space off clouds, ice, and light-colored surfaces, and absorbing the rest, which eventually radiates back out as heat. When those 2 numbers roughly match, global temperature stays stable over time. When more energy comes in than leaves, that surplus does not vanish. It accumulates, mostly warming the oceans, which store the overwhelming majority of the planet's excess heat. Scientists measure this using satellites like NASA's Ceres instruments, which track reflected sunlight and outgoing heat radiation continuously since the early 2000s. A doubling of the imbalance does not mean warming will double overnight. Climate systems respond with lag and complexity. But it does mean the underlying pressure pushing temperatures upward has become measurably stronger. In a fairly short 25-year window, researchers point to 3 overlapping causes behind the falling reflectivity. First, low, bright clouds over the subtropical oceans. Some of Earth's most effective natural reflectors have measurably contracted in coverage. Second, retreating sea ice and mountain snow expose darker ocean water and bare ground underneath. And dark surfaces absorb far more sunlight than white ones, which then accelerates further melting. A self-reinforcing loop scientists call the ice albedo feedback. Third, decades of successful clean air regulation across Europe, North America, and parts of Asia has sharply cut the fine particulate pollution that, alongside its serious health harms, also happened to reflect some sunlight back to space. None of these 3 drivers alone fully explains the trend, and scientists are still working out exactly how much weight each one carries. But together they point the same direction. Less reflected light, more absorbed heat. The aerosol piece deserves its own moment, because it is genuinely counterintuitive. For decades, industrial pollution filled the air over major population centers with fine particles that, among their harmful effects on human lungs, also scattered sunlight back into space, acting as an unintentional, low-grade shade. As countries tightened air quality laws, hospitalizations from pollution dropped and skies cleared. An unambiguous public health win. But climate researchers now describe that cleaner air as having quietly unmasked warming that particulate haze had been partially hiding. This does not mean clean air regulation was a mistake. Nobody studying this argues we should pollute more to cool the planet. It means the true pace of greenhouse gas-driven warming was, for years, partly obscured by an unrelated side effect of pollution control. And removing that mask reveals a starker underlying number than the temperature record alone showed. This finding rests on roughly 25 years of continuous, high-quality satellite data, which sounds like a lot but is genuinely short in climate science terms. Where natural variability can persist for a decade or more, Scientists still disagree on exactly how much of the reflectivity drop comes from cloud changes versus aerosol cleanup versus ice loss. And pinning down those proportions precisely remains an active, unsettled research question, not a solved one. This data is also fueling serious proposals for solar geoengineering, deliberately injecting reflective particles into the atmosphere to artificially restore lost albedo. An idea with real physics behind it and real risks that are nowhere close to being fully understood or tested at planetary scale. Treat this study as strong evidence that warming's underlying engine is running hotter than expected, not as a green light for large-scale, unproven planetary interventions. Quick recap. Satellite records show Earth's reflectivity has fallen roughly 0.6 percentage points since 2000, driven by shrinking low cloud cover, melting ice exposing darker surfaces, and cleaner air removing a layer of sunlight scattering pollution. And together those factors have more than doubled the planet's energy imbalance. So, signal or noise? Signal. This is measured satellite data, not a model projection, confirmed across multiple independent research groups. And it explains part of why recent warming has outpaced some earlier forecasts. Noise risk creeps in whenever this gets used to declare one single cause certain, or to justify untested geoengineering as a quick fix rather than a genuinely risky, unproven idea. The honest takeaway: the planet is absorbing more heat than it used to, for reasons scientists mostly but not fully understand yet. Subscribe for Climate Science Explained without the doom or the denial. Signal from the noise. Every week.